y-axis and the origin. So let me give you a brief description of what symmetry is. So if you have a parabola that's like this, and this is my y-axis and this is my x-axis. So that's the middle of the parabola. When I fold, okay, on the y-axis, all the points here will fall on all these points, and they fall on top of each other. When that happens, we say symmetric to the symmetric to y-axis. So, what about x-axis? Now, if you have a parabola that goes sideways like this, okay, and that's my x-axis, and that's my y-axis. Now, when I fold on the x-axis, this is symmetry to x-axis. Okay, when I fold on the x-axis here, okay, all the points here on this parabola will fall on these points right here on the parabola. When that happens, we say symmetric to the x-axis. And the third is symmetric to the origin. Okay, symmetric to origin. Okay, symmetric to origin means that when you have a graph like this, okay, this is symmetric to the origin because these y values here are exact opposite of the y values that I have here. So then when that happens, it's symmetric to the origin. So it could look like that, but when it's symmetric to the origin, it can also look like this. Okay, so these are y values are exact opposite of these y values. So it's symmetric to the origin. Okay, all right. Now we know what the pictures of x-axis, y-axis, and origin look like. Now let's take actual functions and see what they mean. Okay, and then before I do that, what I want to do is I'm going to go back and take a look at y is equal to x squared. We know that's a parabola that looks like that. You should know that by now. Okay, and then we also should know, okay, why am I stylus? Okay, there you go. Fixed it now. Okay, we also know why. We also know that this is symmetric to the y-axis. Okay, because when I fold on the y-axis, they fall on top of each other. This line falls on top of that line. Okay, now we also know when I put in 2, and I'm going to get 4. Put in 2, I get 4. When I put in -2, I get the same number, because -2 squared is 4. So when that happens, okay, when, let's say, if you pick it, don't try to pick 0 and 1s because they're kind of unique. Let's say f of 2 is same thing as f of -2, and they're equal to each other. If you get the same thing, it's symmetric to the y-axis. Alright? Now let's look at that x is equal to y squared. That's the other parabola, which goes sideways. Okay, when you have something like this, we know it's symmetric to the x-axis. Okay, but how do I check for that? Now, if I replace 2 for the y and the -2 for the y, my x value turns out to be 4, and same thing. So that means when I put in a 2 in place of the y, and when I put in -2 in place of the y, and I get the same answer for the x, then it's symmetric to the x-axis. Okay, so for this is symmetric to the x-axis. Okay, so that's an easy way, a quick way of checking it. Okay, and one more thing, the origin. How do you check for that? So this graph like this, that's an equation of, let's say, y is equal to x to the third. Okay, and that's what that is. And we know it's symmetric to the origin, but how do you check it? If you put in 2 right there, you're going to get 8. And then when you put in -2 in place of the x, we're going to get -8. So when you get exact opposite, okay, then it's symmetric to the origin. Okay, so f of 2 is opposite of f of negative 2. Okay, so it's symmetric to the origin. Okay, so let's go ahead and look at some of the problems. Let's say this is section 2 and this is number 2. Okay, you have y is equal to x to the 4th minus x to the 2nd plus 3. Okay, so you can put in values for x and check, and that's easy. But when you put in values for y, that's not so easy, because what if you put in like a 2? And how do you solve for x? You got to use p over q's and everything to solve for that, so you don't want to do that. So there has to be an easier way to do all of this. So simply, we're going to do this. Here we go. We're going to check for y-axis. Okay, y-axis symmetry. We want to see if it is or not. So every place you see an x, you're going to replace that with a negative x. So y is equal to negative x to the 4th minus negative x to the 2nd plus 3. Okay, so when you replace x with a negative x, and that's what we just did, and then when you clean it up, when you raise negative x to the 4th, you're going to get positive x to the 4th, minus when you raise negative x to the 2nd, you're going to get positive x to the 2nd, plus 3, and it turned out to be exactly same as that. So when I replace that, and then it turned out to be the same, then we say it is symmetric to y-axis. Okay, how do you check for symmetry to the x-axis? Okay, so this time we're going to replace y, that y right there, with the negative y. So negative y is equal to x to the 4th minus x to the 2nd plus 3. If this turned out to be the same as this, then it's symmetric to the x-axis, and it's not, because there's no way this is going to be the same, okay, as what we start out with, so it is not symmetric to the x-axis. Now, how do you check for the origin? We're going to do both of them at the same time. So we're going to turn y into a negative y. We're going to turn all x's into negative x's. Okay. Plus 3. Now, if after I clean this up, if it still turns out to be the same, then it's symmetric to the origin. So there's nothing to clean up here to get a negative y. Well, when I clean this up, that just becomes positive x to the 4th. When I clean this up, I'm going to get x to the 2nd plus 3. So the right-hand side's okay, but look at the left-hand side. That doesn't look the same as this one, so it is not symmetric to the origin, so it's only symmetric to the y-axis. Okay, so let's do one more in this section. Let's go to number 4. This is section 2. Number 4. You have x times y minus square root of a 4 minus x squared is equal to 0. Okay, we're going to check for the symmetry. X-axis, y-axis, origin. Okay, let's start with the y-axis. Okay, how do you check? You're going to replace x with the negative x. Every place you see an x, you're going to replace with a negative. So negative x, y, minus square root of a 4 minus a negative x quantity squared is equal to 0. After you make the replacement, you're going to clean it up. Okay, there's nothing to clean up here, so minus square root of a, have a 4 minus, clean that up, and that turns into positive x squared is equal to 0. Is this exactly the same as that? No. Okay, because this negative here is not there in the original one, so it is not symmetric to the y-axis. Now let's check the x-axis. X-axis, we're going to replace, this time we're going to replace y with a negative y. So it'll be x times negative y minus square root of a 4 minus x squared is equal to 0. Clean this up. Negative xy minus square root of a 4 minus x squared is equal to 0. Now, does this look exactly like what we start out with? No, because this negative here again is a problem, so it's not symmetric to the x-axis. Now we're going to check for the origin. Okay, so what do we do when we check for the origin? We replace every x with a negative x and every y with a negative y. And if it turns out to be the same, then it has symmetry to the origin. Well, negative times negative is positive, so I'm going to get xy minus square root of a 4 minus, when I square the negative x squared, I'm going to get positive x squared is equal to 0. Is this exactly the same as what we started out with? Yes. So then we say yes, it is symmetric to the origin. That's it for symmetry. Okay, that's how you check. First, for the y-axis, replace all the x's with the negative. Second, for the x-axis, replace all the y's with the negative. For the origin, both x and y with the negatives, and clean it up. Okay. Okay, the next section I want to cover is section 5. So this is section 5, and we've done this before, so it'd be pretty easy. So I'm going to do number 3, and we're just checking for the domain. We don't really care about the range. Okay, just the domain. Okay, we'll take care of the range when we get to calculus. X minus 1. Domain means what x values can I exclude. Okay, so right there is a square root. That means this always has to be positive. Okay, otherwise I can't use that. So that means I'm going to set my x minus 1 greater than or equal to 0. And I solve, I get x is greater than or equal to 1. And that's my domain. Okay, that was easy. But let's take a look at number 4, where you have h of x is equal to square root of a 25 minus x squared. Again, I have a square root. That means this has to be positive. Otherwise, I can't take square root of anything. So I'm going to set 25 minus x squared is greater than or equal to 0. And I have to solve for x. But I can't because it's a quadratic. So I have to do number line analysis. So before I do number line analysis, I have to factor. And it's the difference of two squares, which is 5 plus x, 5 minus x. And then when I solve for this, I get x is equal to negative 5. When I solve for this, I get x is equal to 5. And my number line, okay, and my critical number, 0 in the middle, 5, and draw a partition. Negative 5, draw a partition. Pick any number that you can use here. 0 looks like a good one to work with. So put in 0 there. This becomes positive. Put in 0 there. This becomes positive. So positive times positive is positive. That means the other intervals are going to alternate. Right. Where is this thing positive? It's positive there. So my domain is, okay, it's between, okay, negative 5 to 5. That's an interval notation. Or you can write x is greater than or equal to negative 5 and less than or equal to 5. Alright, so that's the domain of the function. So there's only one more thing I need to cover, and then we should be good to go. So let's do section 6. Or section 7. Yeah. So section 7. Okay, and then this is number 1. There's only 3 problems, so I'll do one of them. You can do the other 2 tomorrow. 4 minus x squared. In this one, they're asking if it's an even, odd, or neither. Okay, so let's go back to symmetry. Similar to symmetry, so it's either even, odd, or neither. Okay, or neither. Okay, what does it mean even? If it's symmetric to the y-axis, it's going to be even. That's what even functions look like. It's symmetric to the origin. that'll be odd. Okay, neither means, so you could have a parabola like this, that's neither, because it's not symmetric origin or the y-axis. And if you have a parabola goes sideways, it's not even a function, so it's neither. All right, now how do you check for that? We're just going to check and see the symmetry, which we did before. So even means we're going to replace x with a negative x. So f of negative x, that means 4 minus negative x squared. And when we clean this up, if it turns out to be the same, okay, then it's even. So this is 4 minus x squared. It turned out to be the same, so it is even. Okay. All right. So what about odd? Okay. So let's take a function. Let's do an example. Okay, which I know is to be an odd function. Okay. And let's say y is equal to x to the third. Okay, now this time we're going to replace x with the negative x. Okay, and if it turns out to be opposite of what it is, then it's odd. So this is going to give you negative x to the third, and this is exact opposite of this, and so it's odd function. Another way to check for odd function is you can replace both x and y with the negatives, okay, which we did. Y is equal to negative y, negative x to the third. Clean it up. Negative y is equal to negative x to the third. And when you divide both sides by negative 1 or multiply by negative 1, you get back to what you started with, then it is odd. So you can either check this way, see if it becomes opposite of it, or replace both of them, and if it turns out to be the same, then it's odd. Okay, so what about neither? So let me do an example of neither. Let's say you have y is equal to x minus 2 squared. That means that's a parabola that's moved 2 steps to the right. Okay, so it's going to be 2, it's going to be like that. Okay, so is that even or odd? Well, it should be neither, because when you replace x with a negative x, so negative x minus 2 squared, it's not the same as that, so it's not even. It's not opposite of that. Opposite of that means y is equal to negative of x minus 2 squared. It doesn't look like that, so it's not even, okay, and not odd. Okay, therefore it is neither. That's what that is. This function is neither. Okay, that's it.